welcome to this 5G podcast. I'm talking today with Oren Marmur, Head of NFV at Amdocs, and this is the second in a series of podcasts where we're looking at different aspects of 5G technology. And today we're going to be talking about unlocking the potential of 5G through open, virtualized, and cloud architectures. I'm James Crawshaw, an analyst with Heavy Reading, and just want to say hello, Oren. How's your day been so far?
Hi, James. My day so far has been great.
Okay, good.
Another day at the office.
Exactly. Well, listen, there's a lot to unpack in the title of this podcast: open, virtualized, cloud. So let's start with the first of those attributes. Let's talk a bit about open. I mean, it sounds great. What's not to like about open? But what exactly do we mean when we say that? Are we talking here about open APIs, open interfaces, so that you can have better interoperability? Are we talking about open source? I mean, that's been a big theme in the industry over the last few years, but it's quite a change from the way the telecom industry has traditionally worked, where they've relied on technology vendors. So, are they really going to start contributing to code and open source projects? So let's start off with open. What's your perspective on that?
So first of all, to your question of what do we mean, it's I think the simplest answer would probably be all of the above. And to a large extent, our view is that open APIs and open standards on the one hand, and open source on the other hand, are not contradictory. On the contrary, one is leading to the other. So if we start by open APIs and open standards, that's definitely a very strong business, obviously technical, but first and foremost, a business objective that most service providers have today, because they absolutely need to start breaking down the siloed approach, the vendor lock-in, and to ensure that they can introduce a much wider range of functions and vendors and so on, and do it much faster. And I think that if you look at virtualization beyond the operational aspects and automation and so on, I think that first and foremost, it's about the ability to create an ecosystem and the ability to introduce vendors much faster. So the way I view it, or we view it, is that open APIs and open standards are the goal, the objective. The means to get there and to achieve that is open source. And I think that, if we look at the traditional hardware space or semiconductor space, we've been used to having standards, and then, chipsets are being implemented based on those standards. In the software world, the only practical way we've seen that you can actually standardize and align the entire industry with a fairly broad ecosystem around one common goal and one set of standards and APIs is open source. This is when we go a bit over 2 years back to the original decision that AT&T took together with us around eComp and putting eComp into open source and contributing a lot of code we've developed prior to that, and create ONAP. It has been based on the clear objective and motivation to create standardization to align that and align the entire industry. So for me, open source is the means to an end, and the clear end goal and the objective is to ensure that we have open standards and open APIs, and we open up this to a broad ecosystem as possible.
Okay. Well, so you mentioned eComp, which of course merged with OpenO, another open source project, and is now the ONAP mega project. And I still hear a lot of skepticism in some quarters from some service providers about that project, about it being really too big, too difficult to implement. So, outside of the AT&Ts and the Chinese operators and maybe Bell Canada, Is it something that you're really starting to see getting deployed in earnest? And if so, is it the whole suite, or is it just particular modules?
Right. So first of all, the short answer is yes. We are starting to see this go well beyond AT&T and Bell and others, and I'll try to provide a bit more details in a second. This skepticism is something we've been facing as a community for the past 2 years. I think part of it is legitimate, because this is a new project, and it's also not an open source project that started from a clean slate. It started from 8 million lines of code, and there was a lot of infrastructure already in there. And to be frank, it is also, to a large extent, there's some FUD being spread out there by certain vendors that maybe have some concerns that this will undermine their current business strategy, and they're trying to make sure that they protect their existing solutions. Definitely as a community, in general, and we specifically in Amdocs, I think one of the two key areas we've been focusing on significantly in terms of ONAP is one, to ensure that it is becoming more and more modular. So if you have the 10 or 12 main components in ONAP, not all of them are required in all implementations. And this is something we're really trying to avoid, and we're trying to show that you can actually, not everyone needs to be AT&T, not everyone needs to deploy everything. And you can start with a smaller implementation and then grow from that point on. The second aspect, besides the modularity, has to do with showing stability and showing that there are more and more contributors. That we started by being very much focused around AT&T and eComp, and Amdocs as the main contributor in there, and by now we have a much larger number of vendors that are contributing, as well as a much larger number of service providers that are actively engaged in defining the requirements, defining the use cases. So this is no longer, I think that if we started by ONAP being almost synonymous with AT&T, now it's become a community. There are more vendors, more operators. And I can tell you that in every single NFV deployment, we have quite a few. A lot of those have been already announced, and some of them will soon be announced. We're using certain ONAP components in all these deployments. So it goes well beyond AT&T and Bell. And I think there are also plenty of good field-proven examples and proof points as to the modularity and as to the ability to customize the solution to specific service providers.
Okay, let's talk about another of the open source projects, the ORAN Alliance. So I've been at the big 5G event this week, and I went to a workshop by the Open Compute Project, and there was a presentation there on the ORAN Alliance, which is a sort of open source project to define elements within that would enable you to build a RAN, a radio access network. But there's another initiative under the Telecom Infrastructure Project that's called Open RAN. So ORAN Alliance is part of Linux Foundation. Open RAN is part of TIP. Doesn't this cause a bit of confusion in the industry when you have different consortia and open source groups sort of trying to tackle the same problem?
Yeah. So first of all, I'm assuming that it does create some confusion. I'm not sure I want to go into the exact details of ORAN and Open RAN and so on, but I think that it is, for good or for bad, typical of the way the telecom industry has been handling itself for the past several decades, and probably will be representative of what we see in the future as well. There are always, because of the size of the market and so many different parties involved, we will see multiple initiatives, multiple standardization bodies. I think in earlier stages of a new market, we probably see too many. And then at some point, evolution starts doing its own or taking its own course, and we see greater alignment and support around one or rather than the other, and that over time leads to others maybe going or fading away. Even in the NFV space, we still see, there's ONAP, and there's ETSI, and there's OSM, and there are different TMF APIs and IETF and so on. Some of them are synergetic and complement each other. Some are overlapping, and there's no doubt that in some cases this multitude of different options and standards and initiatives is creating confusion, because in some cases it leads to service providers sitting a bit longer on the fence waiting to see which one would prevail. So in some cases I would definitely like to see more standardization and more alignment coming in, and more convergence coming in at earlier stages. But it is what it is. We're probably not going to change it overnight. Yeah.
And you touched on NFV there and the whole virtualization topic. That transition from physical network functions or devices to virtualized network functions, that's something the industry's been working on for at least 6 years. Is it now sufficiently mature that it's going to, it's going to enable 5G? Because at 5G, a lot of the core network elements is assumed that they are virtualized. Is virtualization mature enough to support 5G, or could it be holding 5G back?
No. So actually, I don't think it will hold 5G back. I think on the contrary, 5G will probably be a significant accelerator and trigger for further adoption of virtualization. If we go back to your original statement, you're absolutely correct. Virtualization and NFV is probably now where we all wanted or where we had all expected it to be when we started this journey 3 or 4 years ago. I think to some extent it's typical of any new technology that always takes longer to adopt than originally anticipated. I think that with NFV it's becoming even more challenging. If I look at the major revolutions the telecom industry has gone through over the last, 15, 20 years. So we had the transition from TDM to IP and things of that nature, and then carrier Ethernet and so on. And these were significant changes or evolutions, but they were not extremely revolutionary. They were basically replacing one technology with a different one, and the organizational aspects, the operational aspects remain pretty much the same. NFV is by far the most revolutionary transformation this market has ever, I think, gone through. And the fact that it is also impacting the entire way the organization is built, changing sort of the traditional boundaries between network and IT, and impacting operational processes and workflows and so on. I think that is creating, in some cases, internal resistance. There's a lot of inertia to fight, and with some operators, there's even greater concern than usual, and sort of a tendency to wait for. It's what I call, the enemy of good is better. You can always wait for something better, but you're not sure what is the right inflection point or when is the right point in time to hop over it. So I think this is what we've seen so far. With 5G, we are obviously not waiting for 5G because we do expect and we're taking very proactive steps to accelerate adoption of NFV even in the near term. I think that no doubt that with 5G, that is the first network technology to be built in a fully virtualized architecture from the ground up. The fact that it introduces network slicing, which is a very complex mechanism that has significant benefits, but also needs to be automated and orchestrated and managed. And the fact that there are also a lot of use cases around edge computing, I don't see how a 5G network, definitely if you wish to monetize it properly, could be run without virtualization and orchestration. And therefore, I think that once 5G does start being adopted, not the early trials just around the radio technology, but the full architecture around network slicing and the new 5G core, I think that will definitely lead to significant acceleration and adoption of NFV and NFV orchestration.
And then you make a good point about the enemy of good being better, but is virtualization the same as cloud? Or when you talk about cloud architectures, were you referring there to containers and Kubernetes and microservices? Is that key to 5G as well?
I think, again, it's all about the right gradual evolution. I think that there's significant value in NFV and orchestration today, even without, fully cloud-native application without containers and microservices. Even if you just take applications and run them as virtualized applications on virtual machines, there are significant benefits as a result of service agility, the ability to introduce services much faster, roll them out much faster, and to introduce a great degree of automation, and specifically to drive towards policy-driven automation and autonomous operations of the network, which will help make a much more compelling business case around networking, as opposed to the current situation where ARPUs are constantly eroding, network investments are increasing, and operational complexity is increasing as well. No doubt that over time, as we see more and more advanced applications if you can not only virtualize them, but if you can also cloudify them, right, and containerize them and so on. That will allow you to further optimize the operations and the benefits. But I think that it needs to be a gradual process in order to make sure that we're not waiting for the solution for too long, and B, it's also on a case-by-case basis. Some applications might make sense to go through more advanced steps of this journey earlier, and others might take more time.
Great. Well, it's a lot to get through, 5G, open, virtualized, and cloud architectures, but we've had a go, and I'm sure there'll be more conversation to be had. But for now, Oren, just like to thank you. Oren Marmur, Head of NFV at Amdocs, and perhaps you can come back later in this series of 5G podcasts, and we can talk some more about network slicing and all that good stuff.
Exactly. Absolutely. My pleasure.
Thanks, Oren.
Thank you, James.